going over sum and difference formula today. So a little trick to remember the sign, sum, and difference formula is just to spell out success and cross out all the vowels as well as the last S. And you end up with S, C, C, S, which is the same thing here. S, C, C, S. Sine, cosine, cosine, sine. Same thing for the difference formula. S, C, C, S. Sine, cosine, cosine, sine. One thing to signify the cosine sum and difference formula is that it is always the opposite operation. That's not the case for sine, because when sine, the two angles are being added, the sum formula comes into play in the expression. Um, but when it is cosine sum formula, notice that the two angles are being added, x plus y. In the expression, it is subtraction. And for cosine subtraction, it is addition in the expression. For cosine, it just doubles up. Cosine, cosine, sine, sine. Same thing for difference. Cosine, cosine, sine, sine. So in this case, we're finding the exact value of cosine 7 pi over 12. The exact value means it has to be in fraction form. So those values can only come from the unit circle. So that means since 7 pi over 12 is not on the unit circle, we have to find two angles that either add or subtract from the unit circle that add or subtract to be 7 pi over 12. Now, the good thing is that when you're adding or subtracting fractions, you are using common denominators. So the two denominators should multiply to be 12, which means you're using either something over 3 and over 4 in radians or over 6 and over 2, because when you multiply them, they have a denominator of 12. So with a little bit of trial and error, I'm going to add pi over 3 plus pi over 4 just to see if I can get 7 pi over 12. You do not have to add up all the fractions by hand. If you use your calculator, just put in fraction form 1 over 3 plus 1 over 4. And then just bring the pi right over, and that'll give you the radian value. So in this case, I am going to add by hand just in case you are doing so as well. So to add fractions, I do a method called crisscross applesauce. So pi times 4 gives me 4 pi, plus, because there's a plus in the middle, cross. 3 times pi is 3 pi. So crisscross over applesauce. 3 times 4 is 12. So when I add up 4 pi plus 3 pi, that will give me 7 pi over 12. So that means I found the two angles. And to find the exact value of cosine 7 pi over 12, I'm going to replace the 7 pi over 12 with the two angles from the unit circle, which is pi over 3 plus pi over 4. So the first angle is x, the second angle is y. So using the sum formula, it states cosine, cosine, sine, sine. Again, you're doubling up. Since this is addition, my expression will say subtraction, and I'm going to just plug in x as pi over 3 and y as pi over 4. Same thing here, x is pi over 3, y is pi over 4. All right, so this is the trick about Module 5. It is always trig, and then from there, your unit circle or algebra, then the unit circle. So once you apply the trig part, know that you're going to take it back to either Module 4 or Algebra 2. You're either going to apply the unit circle or you're going to do some algebra. So in this case, we have some unit circle values. The cosine of pi over 3. If I look at the unit circle, the cosine of pi over 3 is 1/2 times the cosine of pi over 4. Cosine of pi over 4 is square root of 2 over 2 minus sine of pi over 3 would be square root of 3 over 2, and the sine of pi over 4 would be the square root of 2 over 2. So once I'm done with my unit circle, I have some operations applying algebra. I could do PEMDAS. Remember, you multiply before you subtract. So to multiply fractions, I go straight across. 1 times square root of 2 is square root of 2 over 2 times 2 is 4 minus square root of 3 times square root of 2 is the square root of 6 over 2 times 2, which is 4. And then from here, I can subtract. Since they are common denominators, I don't have to do a crisscross applesauce. I can just keep the common denominator and combine the numerator together. Hope this helps.